Today we will start the new topic, that is tree. What we have studied, that is all our linear data structure like array, linked list, single list, or double list. So by the name itself, you can understand that what do we mean by non-linear, which is not linear. But technically, exactly what does it imply to say non-linear data structure? What happens in the main difference? This is the main difference. In linear data structure, each and every record will be connected to a single record directly. But if you want to connect a record with more than one record and in different way, right, that becomes a tree. Like a tree has different branches. We really can't predict how many branches uh, will be there for a particular stem or a particular tree. So this way, nonlinear data structure, we can have separate path, different path, connected with different nodes, and definitely there will be a starting node or root node, you can say. That's why the name has been given, the tree. You have already studied in your mathematics subject graph, right? So graph can be considered a special type of tree, right? Different edges, different paths, like the D-star shortest path algorithm, right? In the graph, so many nodes are connected. One node is connected to the different nodes. So you are having different paths, right? According to the weight of the paths, you are supposed to calculate the shortest path, right? So you have already started this. That is what we have to know uh, in data structure. So I will give you the notes, the different types of tree. We will get a lot of questions from this tree, theoretical questions. Mainly the theoretical path you have to, theoretical part you have to study, and some problems will be given. So let us start the presentation. Let me start with the overview of tree today. Okay. Screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
The topic data structure algorithm tree. Tree represent the nodes connected by edges. We will discuss binary tree or binary tree. Mainly, we will study in this subject the binary tree and general tree. Today, I will give you a brief discussion what we mean by the tree, this binary tree or general tree. You know that by the name itself, binary tree, definitely binary tree has the two derived nodes from a single source. So you can tell that source as a parent node and the derived node derived from this parent node may be considered as child nodes. What happens in binary tree, a node, but any node can have at most two children, not more than two children. It may have no children, or it may have one children or two children, but not more than two children. It will have, right? So maximum permissible number of child nodes will be two in binary tree. But in general tree, there will be no limitation. Okay. A tree may have more than two nodes also in general tree. Okay. Today we will study the binary tree. So binary tree is a special data structure used for data storage purpose. A binary tree has a special condition that each node can have a maximum of two children. A binary tree has the benefit of both an ordered array and a linked list. As such, is as quick as in sorted array. I will describe all this later. How, with the help of ordered array, we can represent a tree, we represent a binary tree, right? So you can say that here the concept of linked list will be used, right? Let's say in linked list, these two nodes are connected, but here the difference is that in a linked list, only one node, that there is interaction between two consecutive nodes. Okay. There was not in this scenario that a particular node will have more than one node. No connection was that in single list because that was a linear data structure, but it is non-linear data structure. Okay. Now different terms are there. According to this picture, you can say that this is called the root node from the tree has been generated. Okay. Root node definitely is a parent node of its immediate label, and these are the labels. Some book follows the label starts with 1, but the most of the books they start the label from 0. So the root lies under level 0, then next level, level 1, level 2, level 3, in this way. According to the height of the tree or depth of the tree, the labels are uh, designed. Okay. And you know that, as I told, that this is the child node of this parent node, and D or E is the child node of B. Okay. B and C are the child node of A. And the nodes at the same level are called siblings. Okay. Siblings, same level. And leaf, and you can also count, this is an the total, the actual tree, the main tree, and you can consider a part of the tree as a sub tree. This is a sub tree. This DHI is a part of the tree, that's also called a sub tree. Okay. And what is leaf? Leaf just like tree, what we call it. Leaf actually uh, lies in the last level where there will be no branches. There will be no branches generated from that leaf. Leaf is the ultimate age of a branch of a tree, right? So in the tree, we call the leaf node. What are the nodes called leaf node? The nodes which have no children. The nodes which have no children. Sometimes most of the students get confused. They generally write the nodes which are at the last level, which is not completely correct answer. Definitely the nodes which are at the last level. Last level means no nodes will be generated from that node. That's why it is in the last level. So the nodes of the last level definitely will be the leaf node, but these are also the leaf node. Okay. You can see F and G are not at the last level, but still we will say F and G at the leaf node. So the definition of the leaf node is the nodes which have no child. It's called leaf node. If it has one child at least, then we will not call this node as a leaf node. Like say for E you can't call the E as leaf node or as J is leaf node, right? So when there be no nodes generated from a node, we call the node as leaf. Got it? Are you getting? It's very easy. Hello.
Yes, yes, sir.
So today we will just discuss the important terms and characteristics of history. You have already studied all these, I think, in your graph. Path, what is path, you know. Root, I already told you, root is the source point of the tree, from where the tree has been generated. Parent, child, I already discussed. Leaf, subtree. Visiting and traversing. Visiting refers to checking the value of a node when control is on the node, right? Traversing means passing through nodes in a specific order. Most these are the actually you can think these visiting and traversing are the same words, meaning not that technically it's a different word. Visiting and traversing. Visiting means after we reach a particular node, if we want to see the value of the node, the content of the node, you can consider each and every node as a record. Got it? Each and every node as a record. Hmm. So after reaching at that node or after reaching at that record, right, from the database, visiting means we are visiting that record, means we are examining that record. We want to see the content of that node, right? That is called visiting. And traversing means if we want to move through that node, let's say I want to reach H here in this node from root node. So traversing means I have to move through B, D, H. So moving through the nodes in a particular path is called traversing. Got it? Okay. I also told about the levels and keys. Key represents as value. These are the keys, right? These are the keys, D, H, I, B, C. Now, if I ask you, these are the technical terms according to the books or I have discussed. Now, let me ask you something. I told you that, sorry, I told you that before you start studying any subject or you start learning any subject, if you don't know the implication or usefulness of this topic, you will not get interested. Mechanically, you will read. The first point, whatever you will be learning, you have to know why you will learn this. So definitely, it's a benefit and real life case. We implement this tree. So if I ask you to think on this, tell me one real life example where tree we have to take the help of tree to implement the real life case, right? When,
Sir, family tree.
hmm?
Family tree.
Family tree. Why I will study family tree? I have not
Sir,
I have not asked you to mention the example of tree. Lots of tree you will get, right? We also everywhere we can see the tree. Like say your an electrical circuit. You can also consider the circuit where the different paths are there. Like say your so many circuit means them Thevenins, right? Or Nortons, right? Hello.
Yes, sir. Yes, sir.
So different branches are there. You are supposed to calculate the voltage or potential of a particular point, right? Isn't it?
Yes, sir.
Consider as tree. So don't give the example of tree. I told you that in this IT and real life project, uh, we how we map this tree concept to the real life concept to uh, develop a project? That I am asking you. If you think, if you can think, could you answer? Just a real life example. Okay, let me.
স্যার ম্যানেজারশিপ যে মানে একটা কোম্পানির যে থাকে
বল বল বল।
কোনো প্রোডাকশন যে জিনিসটা থাকে, প্রথমে একজন ম্যানেজার হয়, তারপর সে আবার তার আন্ডারে দুজনকে কাজ করে, তারপর তাদের লেবারকে ভাগ করে দেয়।
না, একটা হায়ারার্কি বলছিস তুই।
হ্যাঁ হ্যাঁ হ্যাঁ
হায়ারার্কি একদম ঠিকই বলেছিস, অর্গানাইজেশন। But to be more specific, I want the answer from in the light of computer science domain, right? In the light of developing a project.
কোনো গেমিং এও তো হয়।
হ্যাঁ বল।
গেমিং এ
হ্যাঁ, গেমিং হয়, বলতে পারবি গেমিং কোন জায়গায়? ঠিকই বলেছিস, গেমিং একটা পয়েন্ট থেকে একটা পয়েন্টে কোন একটা অবজেক্টকে মুভ করতে গেলে ওই নিডটা। But this all are the abstract answer. It's true. It's right answer. Okay, all the answers are right. But you have to. I want you to be specific. Suppose when you when you got admitted in BBIT, you are a bona fide student of BBIT. Right? So definitely, the BBIT has records for all the students, right? And definitely that is stored in a database, isn't it? But do you think that in one single file, all the informations about you are stored? Not obviously. There will be a master file for each and every student, which will contain your personal details, your name, your date of birth, your gender, and not only your name and your roll number. Let's say map out roll number. This roll number is unique, right? Roll number will never be duplicate one, isn't it? Hello.
Yes, sir.
All
Yes.
the students have unique roll number. So your identity, your identification is mainly your roll number. Because with the same name, more than one student may be there in a class, isn't it? The name
Yes, sir.
may never be the uh, unique item. Now this item, and these are called actually fields. Like in a structure, different member like fields, name, ID. So this unique ID, unique value or unique field is called the primary key, KUI. Each and every field in a record is called key. And there will be an unique key that will designate, that will signify, that will depict that particular record specifically. So that may be called, that table means where the names with the university roll numbers in electrical third year are stored. That table is called the master table in database technically. And from that master table, means from that master record, now one derived record or derived node containing the information will have your personal details, your parents' name, your address, your age, your gender, all this. Okay. Now another pointer will be there. Means from that point, your unique ID from that record, source record, that is what is called the master record. Another record will be pointing for, let's say, your academic record. Personal details, academic details. From academic details, there will be so many records, derived records you can get. Let's say your first year record, your second year record, your third year. From first year record, again another branches or more than one branches may be required, which will assign the details of the marks you got in every subject. Understood? So this hierarchy, whenever the software developer develops a particular software, the first and foremost thing is the feasibility study. That software is designed to meet the requirement of the clients, means users, isn't it? Which who will buy this software, buy this product. So according to the requirement, they will develop this. So that must be user friendly. User friendly means it will meet the requirement of that particular users, right? So first job is to have a sitting, repeated sitting with the clients to understand their requirement. Next is feasibility study. So whether this is feasible technically or not, considering the potential of that company, considering the resource infrastructure of the company which will develop that product as software, that is called feasibility study. Then SRS come, specification, system requirements, right? What will be the system, right, infrastructure required to develop this project. Then DFD, data flow diagram, means they will supply some data. We have to store actual data because all the processes, all the programs which the developers, software developers will write, that will work with what? That will work ultimately with the data, isn't it? Every time we are processing data, I am taking your class, means I am sending some data, you are replying, you are sending some data, I am receiving it, right? Isn't it? So the data needs to be handled. So first of all, how we have to store the data, so we have to think for a database. We have a lot of database in software where we can put the data. So using that database software, we have to create our own database. This will be a database for the student. This will be a database for the faculty. This will be a database for the managerial staff. This will be a database for the clerical staff, right? And each and every database may have multiple tables, doesn't it? And each and every table may have multiple records. Understood? So this way, a tree is generated eventually. You got it? Hello.
Yes, sir.
Yes, sir.
Yeah. So you will not get this concept completely with this real life example in any book. You will study database, you can study this individually, but you have to ultimately club all these topics to get the concept regarding the actual scenario happens while designing, while developing a project, entire project. That's why an entire project is a teamwork. It's not a job of one or two persons. A team gets formed. Okay, maybe that a portion of the project will have a team leader, team lead, and under a particular team leader there will be a 10 senior software developer. Under each and every senior software developer there may be another 10 junior software developers, right? So this way actually the in modular approach, we call it this way, a software gets developed. Okay, modular. So coming back to the yes, the screen is visible, na? Hello.
Yes,
Yes,
sir.
sir.
So I already discussed. So this is a binary tree. Here you can see that at least one node will have maximum 2 children. Right. Now the binary search tree. Now you have to study binaries, which is very, very, very important. You just look at the picture carefully with the full concentration. Full concentration. There is a root of the tree is 27. These is the tree, right? And this is also a tree. Also a tree. You just cut this off, considering this is not there. You just consider. So it looks like same, right? Looks like same, isn't it?
Yes,
This
sir.
and this tree looks like same. Both are binary tree. My question is, what there is a difference? What is that difference between these three? Look at the picture carefully. Between these three and this tree, what is the difference? There is a difference. What is the difference? Who will answer? The pattern or design of the tree is same. Both are the binary tree. But there is a difference between these binary tree and these binary tree. Got my question? What is the difference? Tell me. Who will answer? Very
Sir,
easy.
value, sir, value.
Not only value, that value বললে ভুল হবে। এগুলোও তো value, ঠিক কি না? A,
हाँ sir.
B, D, each and every character has a specific ASCII value.
Hmm.
It's alphabet value, it is a numerical value. So শুধু value বললে ভুল হবে। এটা ঠিক correct answer নয়। What is the correct answer? ভালো করে দেখ, এটা ভালো করে দেখ।
স্যার আগেরটার ভ্যালু গুলো তো সিরিয়াল, বাট এই ভ্যালু গুলো তো সিরিয়াল নয়।
কিছুটা গেছিস, কিছুটা গেছিস। কোনো একটা প্যাটার্ন ফর দেখতে পাচ্ছিস? ডু ইউ সি আ পার্টিকুলার প্যাটার্ন অফ সিকোয়েন্স according to the arrangement? Could you see a particular pattern? Could you notice? You are right যে একটা সিরিজ করা, অথবা সিরিজের মধ্যে কোনো কিছু স্পেশাল,
স্যার এখানে ইকুয়ালি ডিভিশন হচ্ছে,
যেমন বুঝলাম না ইকুয়ালিটির মধ্যে।
মানে স্যার এখানে 14 থেকে দুটো হচ্ছে, কিন্তু
এখানেও 14 থেকে হচ্ছে, এখানেও দেখ এখান থেকে দুটো হচ্ছে, 2 থেকে দুটো হচ্ছে। আমি তো বললাম এটা বাদ দিয়ে দে, ধরে নে এটা নেই, কনসিডার কর, ধরে নে এটা তাহলে সেম। তাহলে ওকে, টাইম নষ্ট করছে না। This is called a binary search tree. A special property is there. You can see that each and every node, left child of each and left means not the left of tree. Who left the meeting? Okay. Anyways, Sayan Roy or something. Here 10 is less than 40. Your left side, not the left side of tree. Okay, don't get it confused. Most of the time the students got confused. They consider that left side of the tree. It's not that. Left side of not left side of the picture. Left side of you means this is the left branch of this tree. This is the right sub branch or side tree of the tree, right? You can see this 14 is the left child of this parent node 27, isn't it? So it
Yes, sir.
14 is less than 27. 35 is the right child of 27, so 35 has the greater value.
আচ্ছা বুঝেছি
31 is the left child of 35 but right child of 27. So 31, this node must have the greater value of this root node and the less value of this node, right? This way. So this is the main difference. This is called binary search. So binary search tree is a special type of binary tree where each and every node will have the left node with the less value from it and will have the right child with the greater value of this node. Binary search tree exhibits a special behavior. A node's left child must have a value less than its parent value, and the node's right child must have a value greater than its parent value. ঠিক আছে? But যদি ইকুয়াল হয় কি হবে? ভুলিয়ে গেল তো? বল এবার মানে বেশিরভাগ বইগুলোই কিছু 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 মানে সব বই কিছু না কিছু ইনকমপ্লিট। কমপ্লিট আমি খুব কম বই দেখেছি। এই মেনশনই করা নেই। যদি ইকুয়াল হয় তাহলে আমি কোনো জায়গায় বসাবো না। অ্যাকচুয়ালি এটা ডেফিনেশনটা হওয়া উচিত রাইট চাইল্ড মাস্ট হ্যাভ আ গ্রেটার দ্যান অর ইকুয়াল। ইকুয়াল হলেও রাইটই আসবে, ঠিক আছে? বুঝলি? অনলি লেস ভ্যালু হলে লেফটে আসবে and had it been the equal or right greater then it will come at right side. Understood?
ওকে স্যার আচ্ছা
This is the main difference. You will get a lot of questions from this binary search tree, theoretical questions, very easy, and lots of scope would be there to get a score, right? So tree node, you can see according to the concept of all linked list, definitely there will be the data part. This data part, if we consider that only single data, so there will be two pointer, left pointer or right pointer. We can say these are left pointer for the left subtree, right pointer for the right subtree. So struct nodes are left child, struct nodes are right child. So each and every node will have two pointer, left and right. Okay. So this is the simple data structure of this node. And basic operations we have to study. And another main thing, after we study the different characteristics, different types, there are so many types of binary tree. In the next class I will discuss, right? Almost binary tree, complete binary tree, almost complete binary tree. I will give the definition, okay, to you. Okay, so you can.
ওকে
So what is the difference between almost complete binary tree and almost complete binary tree? Mainly this is an example of almost complete binary tree. Why almost? See here the tree is almost filled up, okay, but only this is yet to be filled, right? So almost complete binary tree. Had it been filled, had it been two child, means if E got another child or F got two child, G got two child, means the last level had it been fulfilled, completed, then it is called the complete binary. But it is yet to be completed, that's why it's called almost complete binary. I will give the definitions of all these terms, right? All these types of tree. Okay. And another thing is that whenever you'll be studying this tree, we have to study the traversal technique. Traversal technique. Traversal means I want to traverse. I want to search a particular node. I have to traverse the tree. So how I will traverse? First, I have to consider this part or this part of this. First, I have to consider left part of the tree, then root, then right part. Or the first root I have to consider, then left, then right. Or first I have to consider the right subtree, then root, or this. So mainly there are three types of traversal technique. One is in-order traversal, another is pre-order traversal, another is post-order traversal. These three types of traversal we have to study. Three traversal: in-order traversal, pre-order traversal, post-order traversal. Okay. See, pre-order traversal means here we are considering the root node first. In order traversal, we are considering the left subtree first, and post-order traversal, we are considering the left, right, then root. Means sequences are different. In pre-order, first root, then left, then right. In order, we are considering the left subtree first, then root, then right subtree. And in post-order traversal, we will consider the left subtree first, then right subtree, then root. I will discuss, I will uh, teach you with an example at how it comes, how we get this sequence, how to traverse, right? Two techniques are there for a particular traversal that I will discuss in the next class. Okay, today I plan just I will give the overview, okay, of this. It is in our traversal is written. I will send you the material, but I don't know whether you'll understand if you study by yourself. No problem. I will make you understand, right? This pre-order, post-order. Okay. And another, most of the time, at least you can be sure that you will get a question in this way, that you will be given a sequence, this sequence, let's say. You know a sequence, okay, and pre-order sequence. Now you are supposed to design the tree, right? Okay, means from this sequence, you two way you can get the question. From the tree, you have to generate the sequence traversal in order, pre-order, post-order, or maybe you will be given two sequence. Mostly, in order sequence and pre-order sequence will be given, and from these two sequence, you have to generate the tree. Then you have to get the post-order sequence. Got it? Hello.
Yes, sir.
Yes,
So
Yes, sir.
I don't want to elongate the class anymore today. This is the basic of the overview of the tree. If you have any question, it's very interesting, right? Here you don't need to write program because that lab is not there in your syllabus. So I don't want to take the class on lab. But if the time permits, if you want me to show the code, then I will show you the code later on after we complete the syllabus. Our first target, we have to complete the syllabus, right? There's three,
Okay, sir.
so many questions we have to, after this tree, binary search tree, or you have to study the general tree, right? AVL tree, all these, so many topics are there left. Okay. So any questions from today's discussion?
No, sir. Understood, sir.
Understood?
No,
Yeah.
sir. Understood.
And all of you just check your routine, modified routine, it will be final. I mean, so far, I don't know, expected that this is the final routine. So, the time to time, I will update the routine, but you can consider this as the final routine. So, try to attend your class in time. All of you go through your routine. I have posted in your WhatsApp group. I think all of you have checked it, isn't it?
Yes, sir.
yes, sir.
Yes.
Okay. So, let's conclude the today's session. Bye. Okay.
Okay, sir.
Thank you,
Thank
sir.
you,
Thank
sir.
you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Okay.